yeah, on the test, it's really going to be mostly over chain rule. First of all, we've seen chain rule kind of weave throughout all the lessons that we've done so far this unit. But the overarching idea for this unit is understanding the relationship between the graphs of f prime, and f double prime. The first and second derivative tests kind of help us in that analysis, but there's really more to it than just the first and second derivative tests. A lot of it is understanding the relationship between whether one graph is increasing and what that means for its derivative. Also, like what happens when the sign of the slope changes, and all these kinds of bits of information. So today it's going to be very brief notes. Okay, I'll try to make it up to you since last time we had a ton of notes to take. And we're just going to look at this graph, and we're going to begin to start to graph derivatives from the original function. I think we're getting pretty close to being able to do this. So we're just going to analyze this graph, try to sketch its derivative based on what we see here, and do a little analysis on that. So let's see here. We've got this curve. The first question is asking, where's it increasing? Okay, so for this graph to be increasing, what has to be true? Slope is positive, right? So in order for this to be increasing, f prime, or the slope, must be positive, right? So f prime must be positive. This is the slope of f. So we can see we've got an increasing interval between b and d. Right? It's increasing there. There's also one more interval where it's increasing, and that's between f and g. We can see the slope is positive there. So the two intervals are going to be between, how's that looking? Oh, why is that looking so hard to see? What's going on here? There we go. B and D, but also between F and G. There we go. Now, we can see that a function is decreasing anytime the slope is negative. So if f prime is negative, the slope's going to be decreasing. Okay, we see two intervals where this function is decreasing, between a and b, and between d and f. Again, what we're looking at on f to determine what's happening with f prime is the slope of f. Don't forget that the derivative is just the slope. That's sort of the theme of the whole course. If you walk away from calculus understanding one thing, let it be that the derivative is the slope. Yeah, that's it. All right. So yeah, again, f prime is the slope of f. We want to know, when is the slope negative? Okay, so that's where the function's increasing and decreasing. But now let's talk about, when is the function concave up versus concave down. Now, I'm going to make an assumption here. I'm going to assume here that C and E are the inflection points. In other words, those are going to be the points where the concavity changes. There's really not enough information here to make that decision for sure, but I'm going to go ahead and assume that to be true just for the sake of argument here. So the function is going to be concave up anytime the second derivative is positive. Now, that's not as easy to see here, but basically what you're looking for on f is for the graph to either be doing something like this or something like this. Right? If a function's increasing, it's got a positive slope. Decreasing is a negative slope. But for concave up, you're looking for the curvature to kind of make a U shape, more or less. And so we can see that's happening. Let's erase all this. we can see that it's concave up here. Oh, I'll try to get the right color. Concave up here and concave up here. And it'll be concave down in between those inflection points. Okay, so it's concave up between A and C, and also E and G. And then concave down, which is where the second derivative is negative, and you have kind of an upside down looking U shape. That's just going to be between C and E. Any questions so far? All right, let's see if we can sketch F prime. So that's F. We're going to try to sketch F prime here. Okay, so we have a bunch of information here. First of all, where is F prime positive? Without even sketching the graph, based on what I know already about F, in what interval should F prime be positive? Where f of x is increasing, right? And so when is that happening here? Between B and D. And F and G. So what I should do here to start to put this graph together is start to label these points along the x-axis. So here's A, that's just 0. And we've got B, C, just kind of trying to line them up with what I've got up here. D, E, F, and finally G. So if F is increasing between B and D, for instance, then that means the graph of F prime needs to be above the x-axis. It's going to be somewhere up here, because F prime is positive in this interval. So the graph's going to be somewhere up there. We'll sketch it out at the end, but I just want to kind of show you the region where we should expect the graph to be. We should also expect that F prime is positive in between F and G, because the slope of F was positive there. So the graph's also going to be, somewhere in this region. F prime is negative whenever F is decreasing. So these same intervals where F is decreasing will be down here. So in between A and B, but also between D and F. So if F is decreasing, F prime is negative, that means that the graph of F prime needs to be below the x-axis between A and B and D and F. Okay, so you can sort of start to see the graph take shape here. Like we can see kind of the regions where the graph would be, but we want to be a little bit more specific about a couple points here. Okay, I want to know, where is F prime increasing? In other words, where is the slope of F increasing? How is that related to F? Well, what's got to be true about F prime if it's increasing? Okay, so what's positive? If F prime is increasing, the slope of what? Of F prime. Well, what's the slope of F prime? F double prime. So if F prime is increasing, then F double prime must be what?
Positive.
Positive. right? So if f prime is increasing, f double prime must be positive. Well, where is f double prime positive with respect to f? What's true about the graph of f if f double prime is positive and the second derivative is positive? It's concave up, yeah. It's concave up when the second derivative is positive. So that means the first derivative will be increasing in the same intervals where the function is concave up. So in between a and c and e and g, f prime should have a positive slope. So we can start to put together this graph, okay? We know that the function's increasing between a and c. We also know that because we change sign here at b, because f prime's changing sign, there must be an x-intercept there. So our graph's going to go up. It's increasing, 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 and then at c, it stops increasing. Right? What's happening between, say, c and e? It's decreasing. The second derivative is negative. That occurs when the original function is concave down. So between c and e, the graph is decreasing, passing through d. Oh, I didn't write it out. Concave down between c and e. And then finally, we have this other increasing interval, between e and g, where f prime should be increasing. And I guess we would need some open dots here, technically, because the derivative is not going to be defined at those endpoints. There's your graph. So let's just look at these two graphs and see if you can make some connections here. What's true about f prime if we have a relative extreme? So like I'm looking at b, d, and f. What's true about f prime when f has an extreme value? It's an x-intercept. Why is there an x-intercept there? Because the slope's 0. So the value of f prime should be 0. All right, if I look at these points here, b, d, and f, those relative extreme values correspond to x-intercepts on the derivative. We have points of inflection on f at c and e. When you have a point of inflection on f, what should we expect to see on f prime? Yeah, the relative extrema. All right, that's about it. Okay, yeah, there's not really much more to elaborate on here. I think we should, work on our homework for the rest of the period, honestly, and just try to keep practicing problems. Does anyone have any questions?